Hello everyone. My name is Dmytro. Today I'll be presenting on a small talk about guide to testing Jetpack Compose. We have a small agenda for this talk. Basically, we will first go through the basics and discover what's new about Jetpack Compose, also how we did the UI testing before and how we do it now. And we will try to write a simple, basic test for the UI written in Jetpack Compose. All right, then we'll go a little bit deeper and we will see how it is going for testing hybrid applications that use both XML and Compose. And after this, we'll dive slightly deeper into Compose testing library, just see what isolated testing look like. In the end, we'll just recap the entire session to just memorize everything we've got here today. All right, so before we start with the first section, what's new about Jetpack Compose, just want to see, could you please put the hands up who uses Jetpack Compose in their application? All right, very good. Good, that's a lot of progress now. Okay. How many of you have UI tests and actually test Jetpack Compose UI? Okay. Still good, good. Okay, good. All right, so we'll first start with what's new about Jetpack Compose, just to brush up on the updates, what it is, just to see, basically what it is. And basically, the first thing you should know about Jetpack Compose is that it's a new modern UI system and it's different from Android View. Basically, the first biggest difference, it is based on composables, not Android views anymore. Composable is also a UI element. However, the way you create UI elements in Jetpack Compose is you write code that is declarative instead of imperative. So in practice, what that means is that when you write code, you do not describe what operations should be done to a UI element to have some particular appearance. Instead, what you describe the UI element that you want and what properties it has, and then it just happens and you have the UI element on your screen. Now, that's so different, so that's composition first. So when you build UI elements, the first thing you do, you create them from bottom to the top. So you create first very small, discrete items, and then you compose them into bigger, more complex elements. Why not other frameworks though? Because as for declarative kind of creating UI, there are also other frameworks such as Anchor, Counter, and you could just use them instead. However, the problem with them is that even though Anchor, for example, looks very similar to Jetpack Compose, they are still reusing the entire ecosystem of Android View. And on the other hand, what we have with Jetpack Compose is completely new and written from scratch, modern UI toolkit. So it is baked by the Google developers, and it is also supports all the essential and more advanced features. Anchor is so far is deprecated, and Contour is, well, not only it's based in Android views, it provides quite advanced features, but so far we now have a Jetpack Compose, and the thing that makes them common is that just they love the declarative UI, and so far there's still different approaches and different frameworks. All right, another difference is that there are semantic properties for UI elements in Jetpack Compose, and that means that UI attributes are not supported in Jetpack Compose. The biggest difference here is that there are no IDs in Jetpack Compose, and therefore you cannot use by ID in the testing frameworks to find some UI element on a screen. Instead, what you have is a test tag, which you use to uniquely identify your UI elements on the screen later in your tests. Test tag works pretty much, as I said, just as a unique identifier, but as for the time when you write the UI, where you go to the code, you walk in a way that you don't really need the ID there, so they just leave us with test tag instead for this. And also different extensions for UI elements, because we had an entire infrastructure for Android views, and now we cannot really reuse it because it's all based on an Android view, and Jetpack Compose is based on composables. So it's just something to keep in mind as well. So yeah, a small recap real quick. Jetpack Compose, based on composables, declarative, composition first. Also, no view attributes anymore, and we're using test tag to uniquely identify UI elements on a screen and find them later in our tests. Now, as for the second section, what I want to see here, what I want to explore here is how the testing looked before and what it looks now. So before, everyone knows we have Espresso, UI Automator, Roboelectric, Caspresso, all kinds of libraries and frameworks to test our UI. However, after the Jetpack Compose got released, we received the Compose testing library. So what Compose testing library provides is a new testing API, which is very similar to the way it is for Espresso as well. Also, there are improvements to synchronization. We'll talk a bit about it a bit later in the further slides. And there is a thing such as isolated testing, which we have in a different section. So as for synchronization, one thing you should keep in mind is that tests do not run in real time anymore. Instead, they use virtual clock. And in practice, what it is that when you run your UI test, what you can see is that screens can, the actions you set it up, they can go almost instantly through all the screens that you have, because Jetpack Compose doesn't use virtual clock, and it will just perform the actions as fast as possible. So on the emulator, what you will see is just goes very, very fast because it is not dependent on the real time. Also, Compose tests are synchronized. They are synchronized by default, which makes it easier for us to manage the UI test, and we can almost remove the idling resources, at least the default definition of them. This is also a big improvement to that the Compose testing library provides. Also, one more thing about the testing Compose, that UI testing Compose are written with their own test rules. So Compose has its own two test rules. The two main test rules. One of them is Android test rule. Android Compose test rule creates the difference between, all right, so Android Compose test rule provides you an environment of the application that you run. So basically you use this test rule where you need to go through the app to get to some screen and then test some functionality. Also, you have Compose test rule, which goes apart from Android ecosystem, so you do not have access to strings or other context or resource related things, but on the other hand, you can test your UI apart from particular platform and discretely. So yeah, apart from the Android ecosystem, more like unit tests, so to speak. What about compatibility with the frameworks that are already there for Android View? So the biggest problem here is that the testing libraries cannot find views, and they usually use ID to that. So Espresso will not find any view by ID because we do not have view properties, but semantic view attributes by semantic properties now. AirPU will not see a view hierarchy, and UI Automator won't find view by ID either. However, when there is a thing, if a view attribute, for example text, has the same semantic meaning as the semantic property for the UI element in Jetpack Compose, basically you can still find text on the screen using the same tools, because semantically they would mean the same, and some of the functionality this way can be shared, and some of the functionality can be tested using the frameworks from both sides. We will see that in the sample further. And therefore, in Espresso, you actually can find some UI elements by their text, and in UI Automator, you can still perform system actions along with that, because the system actions is something that outside of your application, but for the inside, you can do the search by the text or maybe by the resource. All right, a quick recap as well. So there is a Compose testing rule, provides a new testing API for you, which improves synchronization, which is done by adding the virtual clock to the execution of the UI test, and also all the tests are synchronized by default already. Also, as for the compatibility with the other frameworks, they can be partially compatible, and we will see more examples next. But so far, we already have a library that allows us to fully test the UI written in Jetpack Compose. Right, now for writing our first test in Jetpack Compose test, this is gonna be a very, very simple screen. We'll just have a blank screen with a button on it that says click. The UI for the screen would look something like this. The main thing that we want to pay attention to is the test tag. Test tag is just a string value in the first place, and you can pass a string value to this function to specify the test tag for a particular UI element. What we can do is we can just set a constant for now, just to make it easier for us to manage the code in the test and also in the code base. And the test tag, what is also important, is created using a modifier. So just a short introduction, modifier is something that you use to extend the basic features of the UI element. You can extend its both semantic properties, some appearance features, and one of the things you can set up with it is a test tag. And so this is common for all the UI elements. You'll be able to write the way you create an identifier, which is test tag in our situation, is through the modifier for all of them. You can also use other semantic properties of UI elements to find them in your tests, but test tag is the easiest and the most straightforward way to do so. All right, now going to code, and when writing our test, what we first need to do is to create an Android test rule. An Android test rule allows you to test and controls app that use Jetpack Compose. We specify the activity that will be run for the test, and which we will start with. And the Android test rule provides you all the access to the resources, context, and other things that are platform related and your application related in the first place. So this is the test rule. The second one, when we are starting writing our test, we first find the button, we assert it's displayed, and then just perform a click. So going through the components that are here, the first thing that we go through is the finder. The finder just looks for a composable that matches a searching criteria. So this is the function that you use to find a UI element on a screen. And then you need the matcher to specify what this UI element should have as a property value to be found by the library. Has tag is just the matcher, which will make sure that the UI element has the specified test tag. So if it does, this is our button, it will be returned, we'll store it in a variable. And after that, we just do the assertion. So assertion verifies that the composable meets a specific condition. And here we just assert that the button is displayed. Then we need to click on it, and to do that we use an action. Action just performs user events on the composable, such as clicks or some other gestures that are available. So basically just 5 things. One is the test rule, second is finder, matcher, assertion, and action. That's the 5 elements of your UI test that is written for Jetpack Compose. All right, and now speaking of hybrid applications, right? Let's say you're in a situation where you already have the code base written in XML and you are just starting with Jetpack Compose. So there are some screens in Jetpack Compose, there are some screens in XML. We have a hybrid application. So for this example, we just have a news app, and this news app just consists of 4 screens. The first one is welcome screen, written in Jetpack Compose. The second one is sign-in screen, also Jetpack Compose, and then feed. And feed is written in XML, a very old activity there, right? Another screen there is profile, also in Jetpack Compose. So we have just one XML screen in the middle of our Jetpack Compose UI test. So the thing we want to verify is that profile shows a correct user email. So when the person inputs data in the sign-in screen, we want to make sure that the email that he entered or she entered is shown in the profile screen as well. So the steps would be, we first click on the sign-in button on the welcome screen. Then we input the details, the email and the password. Then we click on continue button to get to the feed. And on the feed, we have a bottom navigation bar, which has the profile item, so we click on it. And then we just verify that the email is correct. Just 5 steps. All right, so let's write a quick test then. So the first thing we do is we create an Android test row to be able to first launch our activity and then test all the screens that are in this flow. We will also just specify some test data for this test. And after this, we are writing our test. So the first thing we do, we are in the welcome screen. We need to click on the sign-in button. And what we do here is we use a node with tag function. So this function just combines a finder and a matcher in a single method. So essentially, it's also a finder, but instead of specifying your matcher separately, you can just use this method to just specify the value of the test tag that should be in a search for the library. So this just combines both things. Now, when we found our button, we are just storing the variable, and after that, we perform a click. So we end up in the sign-in screen. Now, we have 2 input fields. We also use a node with tag to find the input fields, passing the test tag of those fields to specify how we find it. And then after that, we use a perform text input function, which is also an action, to input some details into those fields. Now we go to the button, and here we also find it with a node with tag, give it a tag, and then just perform the click. Okay, now when we are in the feed screen though, you can see that now to click on the profile item there, I just use the espresso function on view with ID, perform click. What it shows you is that what you can do is you can have the test rule for Jetpack Compose. You can have a test for Jetpack Compose, but then you can just use Espresso for the UI elements that are written in XML in Android views. And it's going to work fine as well. So you can still use other frameworks in your test for Jetpack Compose, but also if you have a screen for XML, you would need to handle resource idleness as well. Right, so we are now getting to the profile screen. Here we will use Jetpack Compose to find the email field, and then just assert the text equals the test account email that we already have. So just 2 functions in a row. We found the UI element, and we assorted some of its properties straight away after it. What we can also do here is we can still use Espresso even for the screens that are written in Jetpack Compose, because as I said previously, if semantics meaning of the properties such as Android tags and just Jetpack Compose text, well, it's the same thing essentially. So what you can do, you can use Espresso to find a text on the screen. If I was an ID, it wouldn't work because there are no IDs, but as long as it's text, you can use it to find the UI element on your screen and verify in this situation that it's displayed. All right. Now, the last thing I'd like to talk about is testing and isolation. So we have a screen like this, just a blank screen with a field, title, and a button. You remember I told you that there is a Compose test rule, apart from Android Compose test rule, which goes apart from Android and your application. And let's say, as for this screen, we have this UI. What we want to pay attention here is the test tag. Basically, we have a test tag for our input field and a test tag for our button. Now, we want to verify that the continue button is enabled after user input. So before that, the button should be disabled, and after that, enabled. Now, when we are writing a test and we want to write it isolated, apart from our application, we create a compose row instead of Android compose row here. So we do not need to specify any activity, because the only thing that our test will have is the UI that we will set as a content in our test code base in this situation. So here we have a function set up, which will be called before the tests are executed. And here we set the content from the screen that is used in our application. So instead of going through our application and actually launching it, we can pass only singly the UI that is in our app and test only it. So here that's what we do. We have our sign-in form from the previous slide and just pass it to the set content function. Now when writing the test, we just specify the expected name first for our field. Then we find the input fields and the continue button. After that, we assert that the input field is empty and the button is not enabled. We perform text input and assert that text contains the expected value, and also that the button is now enabled. So what you can see here is the test is written pretty much the same way. However, because we run it apart from the Android application, we do not reuse any of the ecosystem that Android provides, any resources or any context, and it allows you to test it in very, very small pieces. Like if you can test your UI elements this way, not only in very small pieces, but also in different states, because they go apart from the application, and it will look much more like you create the unit tests, but now for your UI as well. So yeah, a quick recap. Jetpack Compose is different from Android View. It doesn't reuse the Android View ecosystem. It provides its own testing library, which provides its own testing API. It has improvements to the synchronization, because tests are synchronized by default, and they are also written using the testing library in the first place that's provided with the Jetpack Compose. You can write tests isolated from your application, which makes it possible to write kind of like a unit test, but for your UI. And yeah, it's if you haven't tried it, it's fun. All right. Thank you all for having me today. I will share this presentation and any other updates on my Twitter, so feel free to subscribe. Happy to have you all here, and thank you for listening. Yep.